This video is designed to give you a little more insight into how we can use traces to really visualize what the 3D graph will look like for a given equation. I'm going to begin by taking a look at the XY traces. Remember, these are specifically the different shapes that we'll get, the curves that we'll get if we pass a plane that is parallel to the XY axis through at different heights z. So let's just first begin by thinking about what sorts of shapes these might be. And I find that it's easiest to do so by taking that z, which we're going to be replacing with various different constants to come up with different traces. I'm going to just put it over with the 25. So one thing to notice here is that this is always going to end up for the XY traces being different constants, which basically means that all of my XY traces will be circles. Now that is, however, a fairly simplified description of the information that I can get out of this. I can get additional information if I kind of think about what are the different possibilities based on the different values of z. So for example, if I were to use z equals 0, then I'm going to get x squared plus y squared equals 25, which is specifically a circle with radius 5. If I use increasing values of z, then I increase the circles. So I can basically picture that on the 3D plane as when I'm on the coordinate plane itself for xy, then I have a circle of radius 5. So I'm just going to kind of draw that circle of radius 5. And if I, for example, go up to a higher value of z, then I'll get a larger circle. And the bigger the z, the bigger the circle. Similarly, if I plug in a negative value for z, I will square that, add it to 25, and it'll have a symmetry there to it. So I can sort of picture these as some of the different traces. And of course, you can do traces at any different value of z in this case. So therefore, not only do I have that my XY traces are circles, I specifically have that the very smallest that gets is going to be right on the XY coordinate plane, and it will be a circle of radius 5. Now, if we take a look at the YZ trace, we end up with bringing the x over, similarly to what we did before, and now we can see that these will be hyperbolas. And we can see the same thing when it comes to the XZ trace. We end up with x squared minus z squared is equal to 25 minus y squared. So we basically can see that we end up with hyperbolas for these two, and then circles, where the smallest radius for the circle that you get here is going to be my 5. And we call this a hyperboloid of one sheet. And a lot of times people get a little confused, like how do you know it's one sheet versus two sheets, etc. So that's kind of the purpose of the rest of this video. Let's take a look at another example. All right, let's take a look at a new example. We have x squared minus y squared minus c squared equals 4. So one thing that is a little bit different here is that now we have more negatives mixed in. And if we take a look again at the xy traces, the yz traces, and the xz traces, let's take a look at how each of those plays out. For the xy traces, we have hyperbolas. Let's take a look now at the YZ traces. I'm going to move this up a little so I get some more space. So for YZ, we have, let's solve basically to get the y and z on one side and the x squared on the other side. And I don't like all these negatives, so if we multiply both sides by -1 and do a little rearranging, we end up with y squared plus z squared is equal to x squared minus 4. Now let's kind of think a little bit about what's happening for x squared minus 4 at different values of x. So specifically, I'm going to look at a few different locations, and they're all going to have to do with plus or minus 2, because that's where this is going to hit that 0 exactly. So I'm going to say, what if x is less than negative 2? If x is less than negative 2, like negative 3, negative 4, then we have circles where the radius is some increasing value as x gets smaller. If x is actually equal to negative 2, then we end up with y squared plus z squared equals 0, which is actually a point. So there's a point at negative 2, 0, 0. If x is between negative 2 and 2, then x squared minus 4 is a negative. So that's not going to work because y squared plus z squared can't be a negative. So that's not an option. And then similarly, if x is equal to 2, we have a point because we end up back at y squared plus z squared is 0. So we have a point there. And finally, if x is greater than 2, then y squared plus z squared equals some sort of a radius, right? So this is circles. So it's a little bit more complicated than just saying the YZ traces are circles. If I were to be a little more nuanced here, then I would say the YZ traces are circles with points at really plus and minus 2. There's 2 points. And a gap between x is negative 2 and x is 2. And just to kind of wrap it all up, if I look at the xz traces, the xz traces are going to be just more hyperbolas. All right, so let's try to envision what this would look like. So I said we have a point at when x is 2, when x is negative 2, and then as x grows, we get increasing circles going this direction and increasing circles going this direction. So we're really looking at these shapes right here, where we end up with, in this case, we would call this a hyperboloid of 2 sheets. And the 2 sheets are being created by this whole situation right here, where we have this gap in between where x values can't exist. Finally, let's look at the equation x squared plus y squared minus z squared equals 0. So again, let's take a look at the xy traces first. For those, I can picture bringing that z squared over to the other side and plugging in different values. If I plug in z equals 0, then we end up with x squared plus y squared equals 0, which is a point in space, specifically at 0, 0, 0. If z is not 0, basically, then we get circles, where the circles are increasing. So similarly to one of the other examples, we end up with this increasing circles, except that we also end up with that point and if we look at the YZ traces, we end up with x being brought over to the other side. So we have y squared minus c squared equals negative x squared. And at first that kind of looks weird, but you could think of it still as just, this hyperbola. And so, again, hyperbola. And similarly, the xz traces would be x squared minus c squared equals negative y squared. In other words, we get more hyperbolas. So if we kind of summarize it, the key here is what's happening for the non-hyperbolas. And sometimes they're circles, sometimes they're ellipses, depending on the coefficients of x squared and y squared, right? If the coefficients are the same on x squared and y squared, then we end up with circles. If they're different, we end up with ellipses. But the thing that I care the most about is really what is happening on that right-hand side. And are we getting always circles greater than a certain radius? Are we sometimes getting to a specific point? What's the pattern here? And so I'm hoping this example will help you guys recognize, when is it a hyperboloid of one sheet, hyperboloid of two sheets versus cones.